Hi guys, welcome to Learning Electronics Repair. I have a Scopemeter here. This is from Handheld, okay? Not heard of this one before, GochiFix, okay? So this is a Scopemeter. This is around $100. Handheld asked me to review this. It is a new released product. But as with all reviews I do, I ensure that I have a free run at this. So this is my opinion. This is my honest opinion. I'm not being paid to say anything specific about this. There seem to be quite a few Scopemeters coming onto the market at the moment. It's quite a busy marketplace. So let's see how well this one works. So we have some meter leads. These look like fairly standard ones. They're quite sharp. They're not needle point, but they are quite sharp. We have a USB-C lead. It seems all these instruments these days charge with one of these. Looks like a quick start. Oh, this is quite nice because without having to read all the way through the manual, we can see the basic operation of this. Basic scope operation and the signal generator operation. This also obviously has a facility to store data, so we have that as well. And handy how to replace the fuse. Oh, this does have fuses, that's good. There's a more detailed instruction manual. And here we have some specifications, so let's start with this. So this is a Cat 2 multimeter or Scopemeter. I think that means it's not suitable for some professions, okay, but that is what we have, Cat 2. We have millivolts, volts, DC AC, frequency, microamps, that's always useful, milliamps, amps, up to 10 amps max, up to 1000 volts DC, 750 volts DC and AC RMS. Within 10 seconds, is this a limit to how long you can actually apply that voltage? I don't think it means 10 seconds to actually read it. Current up to 10 amps within 30 seconds and 15 minutes of cooling interval. Okay, so you can't pass high currents through this for a long time, but that's fairly common with most multimeters. Looks like it gives you an audible warning and visible warning if you're reading voltages over 24 to tell you actually reading high voltages. Okay, and a few other limitations on current if the voltage is above 250. Okay. Oh, this uses a control knob to select the ranges. This is probably easier to use than the ones where you have to have 7 fingers and press a whole sequence of buttons to change the mode. Okay. It also shows you that we go to this range, volts AC DC, to work the oscilloscope. Here's the display. This is like one of those Space 1999 displays I had on the other Scopemeter I reviewed actually. I think it's a matter of taste. It was very visible. We'll see how this one is. It looks like this gives you a lot of information. So this is the warning that you have high voltage present on the meter probes. Set the range, auto, fixed, I'm guessing. Quite a bit of information on there. Yeah, here's the operation of the dial. I actually prefer this to having many buttons. This has a separate resistance, continuity and diode mode. Be interesting to see how the bleeps work on this for all those aficionados of Mr. Bleep. Okay. Here's a bit of information about the oscilloscope. This is interesting because it says simulation bandwidth. Okay. DC to 8 megahertz and then DC to 12 megahertz. It's not particularly sensitive for a scope, but then this is a Scopemeter. So let's see how well it works in that application. Yeah, time-based range, input resistance 5 meg. Okay, so they give us quite a bit of information about this. And the multimeter. So Let's see, the lowest DC voltage is a 600 millivolt range. Same on AC. 600 microamps. So resolution is 0.1 microamps. Yeah, resolution is 0.1 millivolt. So it's reasonably sensitive as a multimeter, to be quite honest. I've seen a lot worse. Again, AC down to 0.1 microamp. Highest range is 10 amp. We can see that. Highest voltage, as we can see, 1000 on DC. Resistance, so resolution down to 0.1 of an ohm. Capacitance to 10 picofarads, okay. Reads up to 99.99 millifarads. That's quite a high capacitance range. And that's all. So the supplied manual is in English only. That may be because I told them, or they know I'm an English speaker. So it's possibly if you have this in a different region, you would get a different language manual, but it's probably worth asking. In fact, I will ask them and put that in the video description. And now it's time to look at the multimeter itself. In a review like this, I'm not going to be able to test every function of this, but we'll give it a good overview to see what it can and can't do in some real life repair situations. So the first thing I noticed, and I like this straight away, this is a scope meter. This is not a multimeter and combined oscilloscope with different inputs for the scope. This is a scope meter, so we have just meter leads, nothing else, and we can poke around at things. This has to be the best one I've seen so far for working on things like switch mode power supplies, because there's no bare metal anywhere to touch on this. This is as safe as any other multimeter, basically, that uses multimeter leads. This probably explains the limited bandwidth of this, because of the fact you're just using meter leads, but I don't think that detracts from the use if this works well. I think this could be a very handy tool for the reason I just explained. So let's power it up and let's see what it does. Well, it does have charge in the battery. That display is really readable. This, I think, is a matter of taste. I like to call this the Space 1999 look. For those of you too young, go and look that one up, okay? It works like a multimeter. I also like that as well. Oh, I quite like as well, there's an off at either end, so it's very quick to flick this thing to off, okay? We'll just attach the leads. The charging port is under here. Okay, but that's well recessed in there. Again, this is in the position that you're not going to touch any exposed metalwork while using this meter. Yeah, that I like. Let's make some basic tests now, and then tomorrow on the live stream, the electronics channel, 5 PM GMT London time, we can have another play with this. So if you can make the live stream tomorrow and you're interested in trying any other functions on here, come over there and let's play some more. But for now, we'll start with the very basics. So resistance, continuity, diode mode. Okay, so, oh, that's nice. It lights up. Oh, and it changes colour. So we get a different colour in the centre of the knob. Yeah, white. It's changing here as well, you can see that, okay. Nice yellow for diode resistance, and then F4 should select the ranges. So this is an auto range at the moment. Yeah, I can see it selecting the various ranges on resistance, and it tells us that on the screen, range select. So select, this changes to diode mode, continuity mode, back to resistance. Then we can go back into auto, okay? So we'll start off with a low value resistor. This is 0.22 ohms. A lot of multimeters struggle to read these low value resistors. This is actually two resistors in series, so from the center to either end is 0.22 and across there is 0.44 ohms. So let's have a look. We'll do it on auto first. And it's reading 0.8. 0.7. What's it reading if I short the leads? 0.3, 0.4. So this happens on my fluke meter as well, by the way. So 0.4, that's saying 0.7, so 0.6, yeah. So if we deduct the 0.4 we have there, that will actually read the correct amount. But let's go into manual range. Let's see if it works better. So we'll go into the manual range. That's the lowest resistance range. Let's have a look. .7, 1.9. Let's measure this on the fluke. So on here, the low resistance range is actually here. Just short the leads together, press the button. So it's zeroed. Let's have a look at the same resistor. So this should be 0.22. Reads 0.4. Reads 0.8. So neither of them actually read this very accurately, and that's what I find generally with multimeters on low resistances. So I won't really deduct any points from this because my fluke doesn't do it any better. .4, 0.5 and shorted. Is about 0.3, 0.4. So yeah, it doesn't do any better than the fluke. Let's go to diode mode. Okay, here we are. So diode mode. What we want is one short bleep, really, and the reading. Reads but knows bleeps. This is what most multimeters do. Okay. This is a shot key. Yeah, it's reading them fine. It's fast. Let's go to continuity. So that's fast, which is what you want on the continuity range. Okay. Will the diodes read in continuity mode? No. So we get what we get with most multimeters, that the bleeping works in continuity mode but not in diode mode. What I'm looking for, you guys have seen this before if you watch my videos, is this. So short, continuous bleep, diode, short bleep in the reading. To be fair, again, almost no multimeters do this. That's a shot key, but in my opinion they all should. But again, I will not deduct any points from this because, to be honest, that's how they all work basically. There's very few multimeters that do this, and there are some cheaper ones that do. I think at least one of the Neng meter does. Let's try some higher value resistors. So again, we'll go to resistance range. It's quite easy to use this, by the way. This is a 100k resistor. Yeah, reading within 1%, and that's the tolerance of the resistor anyway. And a 10 mega ohm, which is the highest value I'm likely to find in repair work. Yeah, reads 10.97. This resistor is supposedly a 1%, but I mean, they are AliExpress resistors, but it's certainly reading it pretty well. Let's see what the fluke thinks of that one. So our 10 meg resistor again. You know, it's reading basically the same as the other meter. I think it's the resistor. So yeah, top marks for resistance range. DC voltage, we'll just do a quick check using my bench power supply. Let's see. Well, that's as accurate as the display on the power supply is. Oh yeah, it bleeps when you go above 24 volts. This is this setting that tells you you've got a high voltage. Let's just try. Yeah, as soon as we reach 24 volts, we get a bleep. We'll try this on mains voltage in a minute. Yeah, it's just a warning, then it stays off, that bleep. Ah yeah, we also get a little display here as well. Yeah, you see the little warning comes on. We also have this light flashing as well. Okay, I quite like that actually. Okay, so let's try the current readings. I'll just use the 10 amp range at the moment. We can have a play with the microamps range on a motherboard where we'll try to read the current draw from the CMOS battery. This is a real life situation where I would want to do that sort of thing. It gives me a very good idea about the condition of the chipset on the motherboard, and that's probably the lowest current I would normally want to read in repair work at least. So I've turned the current limit to a low value. We'll select current on the multimeter. 10 amp range. Okay, let's see what we get. Well, we're in current limit straight away, reading 10 milliamps. My power supply is saying 10 milliamps. This has an extra digit of resolution. So we now have, well, this is saying 150, 160. But again, that doesn't have that extra digit, okay. Yeah, 23, 24, it's reading basically the same. Let's just turn this up. So this power supply is limited at 5 amps, and that's reading 5 amps. Now it said you could read 10 amps up to 30 seconds. This is quite common for a multimeter to have a limited time for a current reading. So I have to say that's working perfectly fine. Okay, now we'll try the AC voltage range. So to do that, we press select to change the range. This is DC voltage. This is now AC. Oh, we can also select frequency here and duty cycle. That's interesting because this also has a hertz range here. But it looks like you can actually measure frequency direct from the AC voltage range, which is quite handy because you may want to know voltage and frequency. Obviously on mains you know what the frequency is, but otherwise you might want to do that. So AC volts, yeah, and the hertz range and the duty cycle. Okay, so we'll go to AC volts. Here we have a mains cord, so I'm just going to put the leads into here. I'm expecting the bleep to bleep because of the high voltage. This will probably put the little sign on as well, so let's have a look to see what happens. So here we go. Yeah, bleeping and 230. Yeah, 3 blips and 230. I do rather like that audio indication that you have a high voltage. It might be handy, you know, when you're sort of probing around the board, it tells you straight away if there's a relatively high voltage on the pin you're probing. And not just but for mains voltages, but for example on amplifiers you can have plus and minus 95 volt rails, something like that, which in themselves is dangerous. If you have a capacitor that's charged, this will tell you straight away, okay, you can read the voltage, but that extra indication I think is a good thing. So AC voltage seems to work. Let's just try the frequency range on that as well. So again, I'll just use the same mains lead. Yeah, it's bleeping And then we go to frequency on here. Yeah, 50 Hertz, very close. Duty cycle should be 50%, okay. So yeah, that works really well. We'll try capacitance range as well. I'm expecting this to do what basically any multimeter does, which is to read capacitors, but the higher the value, the longer it takes. So this is a 220 nanofarad. Yeah, 289. Remember, these things are not made to a close tolerance. This is a 3,300 microfarad. So I'd expect it will read it. It'll just take several seconds, maybe up to 10 seconds or something, to actually do it. Let's have a look. Okay, so nothing happens. It zeros. And then it reads it. Actually, that's quite quick for a multimeter. That's quite quick. We'll just short it. Again. Zeros. Reads it. Yeah, that's not bad at all, actually. Obviously, a dedicated capacitance meter will do it instantly, but that's pretty good. I'll try the low current range. Milliamps, and we'll go on to the microamps range, okay. So this is where I try to read the current draw on a CMOS battery. This is a known good motherboard, it's my test board. So it's about 1.8 microamps or something. To measure this, we press on the battery, we press on the little metal tab and we push it back. 1.9, that reads it, and that's not common. A lot of multimeters will not do that. Yeah, that is good actually. You know, in use already, I have to say I like this. Let's power it up and we'll try a few tests. So we'll see if we get to the oscilloscope range, because I'm sure you all want to see this. Another thing I've just noticed with this actually is this little brightness display. Yeah, if we press this once, this display goes brighter. It's not a backlight, I don't think. I think it just literally increases the brightness of the display. That's unusual actually. Now let's try the oscilloscope. I'll do some basic tests here. Again, get over to the live stream tomorrow and I'm sure we can play around more with this, because I think you guys are going to be interested in this instrument. So the first thing I'm going to try is the real-time clock crystal. We can do this when we're just running from the CMOS battery, and we see we have it there. So it's telling us we have about half a volt peak to peak. I'm not sure I totally believe that, but that's what it says we have. But we can see it clearly at 32.6, 32.7 kilohertz. That's what you would expect. The next thing I'm going to try is the CMOS to see whether, or rather when, because this is a working motherboard, it accesses the CMOS. I'm actually going to attach the black meter lead to a crocodile clip, just to make this easy for me, one-handed, okay. Let's see if the scope meter is quite happy with that. So once again, actually, let's just go to the real-time clock. Yes, it's good. Let's go to the chip select on the BIOS. So this is pin 1 on the BIOS chips. We see this motherboard has a main BIOS and a backup, so you'd expect it to read just the main BIOS. So pin 1, okay. Start, and we expect to see the voltage go high, then a sequence of low voltage pulses. Let's see what we get. Yes, see them there? So I think it's actually set to AC, this scope at the moment, rather than DC, the way it didn't actually go to a fixed level. But we saw it quite clearly, and all we really want to know is, does it access the BIOS? So again, main BIOS, start. Yes, we can see it clearly, okay? If we go to the backup BIOS, we'd expect it not to access this one. Let's have a look. Yeah, exactly what we expect. So that's working fine. And now I will try to look at the waveform on the VRM. So the coils are here, the MOSFETs are here. Let's start the motherboard. Okay, let's have a look to see what we have. Well, we can see a lot of spikes there, but I don't think that's the right point. I think I need to get to the other side, which is over here. Yeah, hit the auto. Well, it's showing something. So auto again. Yeah, I can see them now. And it's showing me that the VRM is running, well, around 300 kilohertz. I don't have a very clear waveform there, but there again, I'm just doing this with a meter probe, so I'm not sure I'd expect it to. But it does tell me the VRM at least is running. Let's try that by manually selecting the voltage range, okay? So that's using these F buttons here. Let's have another go. So once again onto the VRM. There's our pulses. What do we get? Yeah, I think we can see the edges of them rather than anything else, but we can see they there. Okay, that range seems to be about the best. Again, we can clearly see the frequency now, and we can see that it's running. And now we'll just test this on a power supply. This is switch mode power supply. I use this a lot when I'm demonstrating test equipment. Ground is hot ground, which is the negative end of this large electrolytic. So we'll connect this to here. This is my ground for my meter, scope meter. The drive to the transformer actually appears on this pin. It's actually here, the drain, but it also goes to here, so that is where we can get our pulses. Okay, I'll just kind of wedge that in there. Actually, again, I think we could probably use a crock clip lead, but we'll do it this way. This power supply, when it has no load, which it has at the moment, no load, goes into a kind of low power mode. So it's running, but like sporadically triggering the MOSFET. So it's effectively like in a low power drain mode, and then when we add a load, which we'll do, it then continually is triggering the MOSFET onto the transformer. So let's see if it will trigger on this. Okay, there, we saw something. Let me hit the auto. Other scopes I've tried have a bit of trouble triggering on this when it's actually on these sporadic pulses, but it has done. It's got one there, it's got one there. Okay, these are the sporadic pulses I was telling you about that come along. Let's put a load on the power supply. So we'll switch it off. You'll see these kind of die away, these pulses, look, to go a little bit wider. And that's because the voltage is dropping, so it needs to effectively pull more current into the transformer to maintain the output voltage. And eventually the voltage drops so low that this will just stop doing it, basically. So he's showing us that that's running. Yeah, still running, although the power's been off for a while, and then it stops. Right, let's connect a load to the power supply. Okay. That's still wedged quite nicely in there, actually leaves my hands free. Now let's try this, and we should now get a continuous drive into the transformer. Okay, yes we do have. Let's hit the auto button. There, and now you can see it running. Okay, I haven't actually set the trigger level. We can do that. So trigger. Yeah, it's triggered now. So we can see 539 kilohertz. There's a nice pulse. It's telling us 115 volts high. So I have to say that works pretty well, considering this is not using a scope probe, it's using the multimeter probe. And the last function we will just have a look at in this quick review is the function generator. So to do this, we plug the red lead into here where it says out. Yeah, function generator out. Okay, we select DC volts on here, and then we hold this button in, and we're now in the function generator. And you can see on my oscilloscope over here we have a square wave. Now we have some parameters on here such as frequency, and from what I can see this allows you to select a number of preset frequencies. Okay, yeah, plus or minus. So you can generate a signal at various frequencies up to 50 kilohertz. Okay, that's the maximum. Yes, press exit and then it changes. So we can go back to our scope. So that's a pretty reasonable square wave at 50 kilohertz. It's not perfect rise and fall time, but that's what we have. That's at the highest frequency. Let's try a few other waves on here. So wave, sine, okay, square, triangle, and then I'll try the volts. This is the output. Yeah, so we can set different output voltages if we want, up to 3 volts. That's fairly common for most signal generators, up to 3 volts. We'll just come down to a lower frequency, say 10 kilohertz. Exit. We can see the waveform on the scope quite clearly. Okay, and then we can change the duty cycle. So duty, let's go up, say, to 90%. I've noticed then that you have to press wave F4. It's a little bit strange, this particular interface. So, but you can see that we've actually changed it to 90% on. Then exit, back into duty. Let's go, say, to 10% on. Okay. And then wave to change it. Yeah, you see we've got a 10% waveform on our scope now. Okay, and exit to come out. So the user interface varies depending whether you want to choose a frequency or a duty cycle. The exit keys are different, either F1 or F4. I guess you can get used to that, but it just seems a little strange that they were both operating slightly different ways. Okay, so we've had a look around this. I have to say, I'm fairly impressed with it, with some slight reservations, but that might be due to what it is. So this is the first time I've used what I would actually call a Scopemeter, not a meter with a oscilloscope added on, if you like, with different inputs. That appears to give some limitations to what the scope can do because we're effectively using meter probes. Yeah, and that doesn't surprise me at all. But it also makes it a very handy piece of equipment if you're fault finding, if you just quickly want to check, as I was showing you, for BIOSes being accessed or something like a real-time clock oscillator is running or a VRM. If you really wanted to look at the waveform, I think then you'd have to get a scope. But if you want to sort of like have a go, no-go indication, this is just something in your hand, and you can certainly use that. You haven't got to mess around getting a different probe or anything else, and for that alone I think it's very useful. Time will tell, but I'm going to use this in some of my repair work, and let's see how well it actually works in real life, although those scenarios were real life scenarios. But as I mentioned, we can take another look at this on the live stream, which is tomorrow, 5 p.m. London time. We have 2 hours. We'll be looking at a lot of other stuff as well tomorrow, but we can have a little bit of time playing around with this. So guys, come over to the electronics channel to watch that with Detlef, Carlos and myself if you'd like to see this in other real life scenarios or some other feature that I didn't show. Okay, I've got to give it a rating, and it's, you know what, I'm not going to give it something out of 10, but I am going to say I rather like this. Okay, I look forward to seeing you all soon on another Learning Electronics Repair video. Ciao for now, guys.